A projectile thrown from the bank of a lake with an initial angle theta with the horizon with an initial velocity u. Find the relative velocity of the shadow of the projectile in the lake with respect to the projectile itself. See, this is the lake and let me throw the projectile. Okay, let me throw it with an initial velocity u. You will see the shadow of the projectile as well. So this is the projectile, maybe it's not a parabola, and this is the initial velocity u. And this is the angle theta. So at any instant of time, the velocity of the projectile will be like this, right? It's tangential to the curve, so it's Vt. Now the point is, the velocity of the shadow will be exactly a reflection of this, right? So it should be in this direction, correct? Let me mention it as V prime t, and let me drop a slight perpendicular to this so that you can identify the position. So this is the position, right? Okay. Now the point is, if I want to find the relative velocity of this shadow, so this is the shadow and this is the projectile. With respect to the projectile itself, I need to add a vector field to stop the projectile, so as to stop the projectile. So at any time t, let me add a vector field which is exactly opposite to v of t. So this thing, so this is minus v of t, right? This vector field gets added with the shadow. And the resultant of this minus Vt and this Vt gives the value of the relative velocity, or the exact value as well as direction of the relative velocity. Now let me find out what's the value of Vt first. So let me break it into components. So this is, now as far as if this is u is concerned, this initial velocity has two components, right? One is in the horizontal direction, so this doesn't change, and the vertical direction of course is u sine theta, right? So this is u sine theta and this is u cosine of theta. Now u cosine of theta doesn't change, so this is u cosine of theta, but u sine theta definitely changes. How? So suppose this is v of y, okay, so v of y will be, so v of y will be u sine theta minus gt, as g is the field acting down, correct? So what is v? If I write it in a vector form, so v vector of t, so that is I cap u cos theta plus j cap u sine theta minus gt, correct? Now what is v prime of t? Now again, as far as this v prime of t is concerned, you can definitely have the horizontal component of v prime of t is not changing, which is u cos theta, but the vertical component, the magnitude of what the vertical component will be same with respect to this vt, but the problem is the direction will be exactly opposite. So v prime of t, so that is I cap u cos theta minus j cap u sin theta minus gt. Now what is v minus t? V minus t, you know, if you know vt, v minus t is just all these expressions with a negative sign. So let me find the relative velocity. So relative velocity of the shadow with respect to this projectile, this is the relative velocity as required in the problem. So this is the relative velocity of shadow with respect to this projectile is basically the sum of these two. So that is the minus vt plus v prime of t. So what's minus vt? So minus I cap u cos theta minus j cap u sin theta minus gt. And what is v prime of t? So that is plus I cap u cosine of theta minus j cap u sine of theta minus gt. Now in this problem, these two terms gets cancelled, so no horizontal component as you see. So that is minus of j cap, that's the direction, times 2 u sine theta minus gt. This problem came into my mind while I was driving my car along by the side of a building which is made of glass. I saw the image of my car, but I couldn't comprehend the horizontal velocity. But as I was turning the car, I feel that it's going in and into the building, and the image of the car is going into the building and coming out of the building. So from that this idea came into my mind. So I hope you will enjoy this problem. Thank you very much.